Presentation is the same as that of last year, but however, I have a little modified. I have put up some viral examples, example of the viruses. Okay. So. So somebody said virus is actually a particle, okay? This is a living L-I-V-I, and this is the dead, okay? Between living, boys, between the living and the dead, there is a line, okay? I am living here. So for an instance, if I die, finish, over. So there is a line, right? Between dead and the living. Virus comes here. However, if this particle, we are not saying virus is an organism, we are saying virus is a particle, okay? What is this? It's here virus. If it gets a chance to enter into the living cell, it becomes live. Otherwise, you can play with the virus like this. You can play the virus live, but you cannot play with the bacteria, okay? It's the main difference. Viruses are infectious. This is the reason we call them, somebody said infectious agent. Who said this? Infectious agent. What does it mean? This means a particle. Infectious agent. He didn't say microorganism. He didn't say living. He didn't use this. This is the difference between bacteria and for bacteria you say it's a prokaryotic organism containing DNA. Last time I told you. But for the viruses, it is an infectious agent. Infectious, that's the capability to cause infectious agent. It contains what?
Contain
It contains DNA or RNA, as it is genetic material. What else is in the virus cell apart from this?
Capsid, protein coat.
Protein coat, right? This is the virus particle. This is a virus particle. It contains either DNA or RNA. This may be single strand. This may be and outside it contains protein coat, which is called as
Capsid.
capsid. And capsid is made up of
protein and
which protein? Which protein? This capsid is made up of protein, and protein is called as. Always remember for the whole life. Capsomere. Capsomeres are a small particles. They join together and form the outer cover of the. These viruses are called capsids, and some viruses have the outer coats. This is the virus. So today we will see how to diagnose, how in the laboratory, or how we can culture a virus in the lab. I told you it is an infectious agent. It's not in a living. It needs necessarily a living thing. It may be a plant. It may be an animal. It may be a human being. Even it may be a bacteria. There are some viruses that attack on the bacterial cells, okay, for their own survival. Some viruses affect plants. We are not going to discuss this. And some animals. As far as this concern, this topic today is related to humans. So we will talk about the viruses that particularly cause diseases in the humans. As we said, this is a dead. It's not in a living. So you cannot culture virus in the laboratory in artificial media, like bacteria. I showed you last time media. Have you remembered something? like McConkey, other type of medium, but for viruses there is no such type of medium. No. Then what? There is what? How to grow virus in the laboratory?
Science,
You need a living cell. You need a
bacteria.
not only bacteria. You need a living cell. One of your friends said tissue, and this technique, this is called as virus is clear. What is DNA? What is DNA?
Bacteria.
DNA.
Deoxyribonucleic acid.
Deoxyribonucleic acid. What is RNA? Ribose nucleic acid. Okay. Double strand single clear. PCR keep it, ELISA keep it, and tissue culture. And tissue culture. Why I am saying the tissue culture? This means virus cannot be grown in the laboratory in an artificial media. You need something living. You need something. Either you can use the chickens, okay? Chickens. You can use the laboratory mice to grow the virus. You may need the rabbits, but they are also a living thing. So for that reason, there is a new technique. It's called as tissue culture. It's very old, but now frequently used in the biology. It's a tissue culture. So what you usually do from monkey, kidney cells taken from the monkey, only one kidney cell. One kidney cell taken from the monkey. This is a kidney cell. Yeah, this is the now human cell containing everything. So what? Please remember, this is tissue culture because later on I will not explain it. This is living cell, okay? Taken from monkey. Very good. And what we do, we put in a glass tube. Glass. This cell is now here. Clear? So what we do now, we add enzymes, okay, cofactors, glucose, hormones, and etc. other things. What we need for our body, the same things. We need hormones, we need enzymes, we need proteins for glucose as an energy. We add it here. We add it here. And we incubate it, okay? We also add the enzyme like trypsin and so on. And we incubate it, okay? The lab is called as tissue culture lab, okay? Keep this in mind. Lab is called as tissue culture lab. This means something where you can grow the tissues. You need a single cell or part of a tissue. This is a monkey kidney cell in the glass tube. We add the things, and after some time, this glass tube is now full of cells. Full of? This cell has a capability to grow artificially. This is the reason, if you remember, the United States 3 years back, they banned the cloning of the humans, okay? If we can take the cells and we put them in a lab, we can grow a human being, okay? But this has been completely stopped. This has been banned in all the countries. There is no lab in the world where you can grow a human, because there will be no control on the earth. But for these type of cells we can grow. You see these cells? These cells are now called as tissue culture cells. Are called as these cells. So what we do, there are different types: primary, semi-continuous, and continuous. Each type of these cells have a property, okay? They have their characteristics. So what we do then when we have a cells, we took them to the virology lab, and this is a battery plate. Last time that I've shown you in the microbiology lab, you put some of the cells, okay, I will make it like this to make you understand. And these cells like this, a monolayer of cells, we put it here. These cells are not living, or living. But tissue culture, it is highly sensitive technique. A single mistake can destroy all. Because you are going to grow, you are growing a cell. You are growing a single minor error, everything is destroyed. In terms of pH, in terms of infection or something. So now you put these cells in this type of tube, then you add the virus you want to culture. The virus you want to Masalan, give me few examples of viruses.
Hepatitis.
Hepatitis, very good. HIV, very good.
Rhinovirus.
Retrovirus.
Retro is the big family. Name the virus example.
HPV.
HPV, rotavirus, herpes simplex virus. Famous example, influenza virus. All of us have at least this year one time influenza, right? Common cold, flu. Common cold is different from the flu, okay? But flu is caused by the viruses. And one of the best examples is Middle East respiratory syndrome. You know about it? Middle East respiratory syndrome, very good. This disease is caused by the coronavirus. Coronavirus is exactly same as that of influenza virus in terms of replication, but it is a dangerous pathogen as compared to the influenza. But viruses, the properties, what influenza do the same, corona do, but it has more pathogenic than influenza. You can grow these type of viruses here. Now how we can see the growth of a virus, we can continue in the labs, okay? So that's it, tissue culture, you understood the point. Tissue culture, the virus, these things are clear. So let's go to the lab. Basically, to isolate the virus, we can go through three ways, okay? One is a direct seeing whether virus is present or not. Direct, like in light microscope, electron microscope, LMEM, and fluorescent antibody, and this is a precipitation reaction, double immunodiffusion. Double immunodiffusion and PCR, polymerase chain reaction. Second, as I told you, to isolate the virus in the laboratory, you can use the tissue culture. Tissue culture, you can use a chick embryo? Chickens are produced from what? Eggs. So when you keep egg in the lab for at a specific temperature, their chromosomes fuse together and the chick is formed inside the egg. When embryo is created, chick is inside the egg. You stop it. And in the meantime, for the shell outside, you insert the needles and inject the virus. Because chicken is inside growing inside the egg shell, and you are injecting the virus, and virus have a capability to grow inside the living thing. This is called a chick embryo. And any lab animal yani mice, either rabbit or something, okay? One of the famous example, syphilis. Syphilis is a disease. Syphilis is a sexual transmitted disease caused by Treponema pallidum. Caused by this bacteria. This only and only grows in the testicle of rabbit. In other places it does not grow. No growth for syphilis in terms of bacteria. So sometimes you need animals also for the growth of bacteria as well as the viruses. Syphilis is an example of bacteria, not of the virus. Okay, second is clear. Number third, immunofluorescence, ELISA, neutralization test, heme agglutination test. These two are related to the cell and the RBCs. I will come to that point. The time is running out. So let's go number one. In the light microscope, once the virus is grown here in this cell, you can see it under the microscope. You can see under that. What you see? The changes. The change in this cell caused by the virus. What are the changes? We will come to the next. Similarly, electron microscope. In the electron, if you use, instead of light microscope, if you use the electron microscope gives you the idea how much big is virus. You can see the virus. You can see that. If you use the light microscope for the bacteria, you can find it very easily inside the microscope. But viruses you cannot see using light microscope. We cannot see the virus by this. Virus can be seen only in the electron microscope. Second is a fluorescent antibody. If somebody is having the viral infection, okay, you take the blood sample from the patient it contains the antibodies, and this is the antigen. The antigen and antibody will combine, and fluorescent means fluorescein dye, and under the microscope it looks like green. This means the antigen and antibody reaction has occurred, and this is the direct reaction. And in the double immunodiffusion, there's a picture for this. In the light microscope, you can see the characteristics of the cell damaged by the virus. It's called cytopathic effect. Cytopathic effect. This cell, when infected by the virus, the changes occur inside the cell. Changes because it will destroy it, right? It's a virus. It shows its replication. This is called CPE. This is called as cytopathic effect. And the changes that occur inside this cell, these are called the inclusion bodies. Electron microscope, it shows the structure of the virus and the diameter and so on. So remember, in the light microscope, you can see the changes. Cytopathic effect. What is a cytopathic effect? It is here. I will tell you now. And in the electron microscope, you can see the shape of the virus. So let's come here, the demonstration of cytological changes. I will tell you on one line. When virus infected this cell, the cytopathic effect that occurs, it's used as a term, it's called as an inclusion body. It's called as single word. If someone will ask you what happens when a virus infects a cell, either in our case or in the laboratory, you can say the virus produce inclusion bodies. So what is the inclusion bodies? Inclusion bodies means mass of viral particles. When virus is injected here, the virus will replicate. Number of virus particles is formed. 1. Second, they will form either in the nucleus or in the cytoplasm. This depends on the virus. They may be intranuclear, they may be intracytoplasmic. And they may be either acidophilic later on or basophilic. Like herpes simplex virus, Bacillus zoster virus, and rabies virus. These are the examples that cause damage to the living cells and produce the effect inclusion bodies. So what are the inclusion bodies now? Growth of the virus, mass of the virus are formed inside these cells. They may be produced inside, if this is a cell, a tissue cell, this is the nucleus, okay? This is the cytoplasm. It's a choice of a virus. He can grow here or here, okay? And destroy this cell. Destroy this cell means internal replicate. And finally, cell will be burst and the virus will be released. These are the examples. And second, cytopathic. This is the inclusion body, okay? Masses, in cytoplasmic or intranuclear. Now, what is cytopathic effect? Cytopathic means first degeneration. Degeneration means of this cell will be degenerated. Nothing will be in order. Cytoplasm will be utilized, nucleus will be utilized, enzymes will be utilized. So degeneration is recognized by rounding. This cell, if it is like this, after the infection of the virus, this becomes round. It will become round. It may shrink. This cell may shrink like this. This way, or ballooning. It may be like balloon like this. It depends upon the virus. It depends upon the. I have given a few examples. Enteroviruses. Enterovirus is called rounding of the cells. When enterovirus affect our cells, cells become round shaped. They are also, but this main example here, shrinking. Herpes virus, herpes simplex virus. You know about something about herpes? Maybe you will have a lecture. Herpes simplex virus. There are two, 1 and 2. The herpes simplex virus, it causes the blisters on the lips here in this region, and this is called in the genital parts herpes simplex virus 2. But herpes simplex virus 2, it has also capability to create the blisters. And paramyxoviruses, it causes the ballooning, shrinkage caused by this virus. Fine. So this is the difference between the inclusion body and cytopathic effect. Inclusion bodies are the masses of virus particles produced inside the living cell, and in the cytopathic effect, what is this? When we see under the microscope, we see cells are big shaped, or cells are shrinked, or cells are ballooning. You see, as this cell dies, now it will not remain attached anymore to this place. You will find it here. This means virus have destroyed it completely. And finally, when it becomes like ballooning, rounded, shrinkage, this is called multinucleate giant cells are formed. Fine? Clear? Inclusion body clear? Cytopathic effect clear? So this we can see here. This is the cytopathic. You see inclusion, you see here. Intracytoplasmic bodies formed by the virus. This negative body usually caused by the rabies virus. The inclusion bodies produced or formed by rabies virus is called as a negative body. But this comes in the inclusion body. This term specific for the rabies virus. You see, this is uninfected cells. When virus affected this, you see what happened? This is called cytopathic effect. Okay? The whole scene. This is called a cytopathic effect. And of course, this is also the inclusion bodies. Both are together, right? Yeah. When there is inclusion bodies, this means there is cytopathic effect. Fine? So this is you see how cells are damaged. All the three terms are here: rounding, ballooning, shrinkage, and after complete destruction, cells will be detached. Any questions still here? This is the electron microscope. We have in Al Jawaab University, we have a one electron microscope. It's present in applied school. This is the virus. If someday you want to see virus, you can go there, they can show you. This is the fluorescent antibody. Direct detection of antigen and antibody reaction using the fluorescent dye, you can find this reaction. You see? Dengue virus and herpes simplex virus, how they look like after the antigen antibody reaction. For example, a patient comes to a clinic, and you are suspecting that he is having a herpes simplex virus infection. According to a microbiology report, what type of tests you would suggest? This is one of the tests, fluorescent antibody. And second is the culture, okay? Fine. Now, double immunodiffusion. What does double immunodiffusion indicate? What does it mean, double immunodiffusion? You have a petri plate, okay? You put in it agar. I told you last time what is agar. You remember? Agar is here. This is agar. Inside the petri plate. And what we do, we make the valves. What does valves mean? The agar, it's in the plate and we make valves. We make the cavities in the circle. Here and here, we add antigen, okay? And in the center, we put antibody. After the incubation of some time, both will diffuse, they will come out from these valves. Antigen will come out, antibody will come out. They will come out, and this is called double. Antigen, antibody. They are coming out from the valves and trying to match each other. This is the result. You see the antigen coming from here, antibody here, and this is the line of this antigen. And this antigen, this is the, it makes like this. And gives you the result. Gives you the, this is called as immunodiffusion. It takes 2 to 6 hours. Why it is called double immuno? This is also called as Ochterlony test. Ochterlony, the name of the person was Ochterlony who developed this test. A soluble antigen, and a soluble antibody. They diffuse from the valves. This means they are coming out from the valves. These are the valves. Coming out and forms a visible precipitate. This is the visible precipitate. You see here, this line. You can see it very clearly. This means you have put the viral antigen here, and this is the serum of a patient. If they match, it will bind to it and gives the result, positive reaction. This means antigen is present. Virus is here. These antigens are the viral antigens. When I use the term antigen, you should understand this is from the virus. Either the protein code, either whatever taken from the virus. Okay. You got my point? What I'm saying? Yes. Okay. These are the antigens and antibodies. If the reaction they react, the reaction is positive. This means virus is present. Now PCR. What is PCR? Now first, light microscope is clear, electron microscope is clear, antibody, double immunodiffusion. Now PCR. I told you last time the PCR, it has the 3 things very important for PCR. What is important for PCR? I told you the bacterial diagnosis. Primer, DNA polymerase, nucleotides. What's a primer?
Binds to the DNA.
No, what's a primer?
It's the RNA.
The initial.
Short sequence of nucleotides. Short sequence of nucleotides. Maybe usually from 9 to 12 nucleotides are there. Primer should not be less than 9 nucleotides. Remember this. What is the DNA polymerase? That carries out the polymerization reaction. What is the nucleotides? Adenine, guanine, cytosine, thymine. If it is RNA, then uracil. So for PCR means polymerase chain reaction. Polymerase from DNA polymerase. Okay. Chain reaction means in the form of chain, the reaction gets increased. The chain reaction is because of the presence of the nucleotides. But when this chain is formed, the chain will be formed only if there is presence of the primer. And the primer is always specific for a disease. And every disease, for example, some person is having the infection of HIV, okay? There will be the specific primer for HIV. Some person is having the herpes simplex virus. It will have a specific type of primer. So the polymerase chain reaction depends on the primer. If a person is suspecting HIV and you are requesting for the polymerase chain reaction, and in the laboratory instead of HIV, if the technician there who is going to conduct this reaction, if he put the primer of another virus fail, he will get nothing. So this polymerase chain reaction, the principle, it is the amplification of DNA sequence. This is its principle. It amplifies. Amplify means it increases, it doubles something. What doubles something? Let us see. The process occurs in 3 steps. Process occurs in how many steps? First is denaturation. Second is denaturation. Second is annealing. Third is extension. You have the DNA. Yani you take a blood sample of a person, you are suspecting this person is having HIV infection, okay? HIV, let us take the example of HIV because HIV has a capability to produce double-stranded DNA. It's an RNA virus, but it has a capability to produce DNA virus. Let's take the example of HIV virus to understand the PCR. The PCR means amplification of the DNA. This is the virus. You are suspecting a person comes to your clinic, he is having a disease of AIDS. You know AIDS is caused by the HIV or HIV. You suggest the PCR. So in the laboratory, the blood sample will be taken from the patient, and now this is the DNA of the virus. In the first step of the PCR, what will happen? Very quickly I will say, it will break down into or separate. The DNA separates from each other due to high temperature, okay, at 94. In the next step, annealing, and this is now primer. This is the primer. Polymerization always occurs in 5 prime, 3 prime direction because DNA polymerase moves from 5 prime to 3 prime direction. This is the primer and this primer here. You know this DNA separated into 2, primer is added here, Now, if the primer of HIV is added here, it will carry out the reaction. If the primer is wrong, there will be no reaction at all. This the primer is attached on both sides here, and finally the extension, and it will catch these nucleotides. DNA polymerase will come here. This is the DNA polymerase. Primer is gone, polymerase is gone. Now nucleotides, these nucleotides are here. These nucleotides will come and they start attacking to the here in this direction. This will go in this direction, and you are having double-stranded DNA 2, and now you got from here you got 2, and from this you got 2. This is called amplification. And once the next, after either for 1 day, usually there should be more than 100 cycles of this reaction. And next morning, when you take out this DNA and pass it through the electrophoresis gel, he will see the bands of the DNA. Lots of bands. We started only from 1 DNA, but next morning he will see lot of bands, and this means there is presence of the virus inside his body. This is called polymerase chain reaction. 3 things are important in the PCR: primer, DNA polymerase, and this is the machine, polymerase chain reaction. Very simple. In this reaction, you take a blood sample, isolate the DNA, put the DNA here of the patient. You are suspecting HIV infection, and you add primer, you add DNA polymerase, you add nucleotides here, all here, everything here, and then you put this inside this machine. You set here cycle, 3 cycles, as I told you, 94 degrees, 55 and 65 degrees Celsius. You adjust here, you write 100 cycles, and you go home. Nothing to do. Next morning when you come, if the primer and the DNA of HIV is present, it will amplify it. It will increase the amount of the DNA. How much increase? Million folds. As much as you can. 2 become 4, 4 become 8, 8 become 16, like this way. Now, let us go for the virus isolation. How we can isolate the virus in the laboratory. You need a sample, either the swab. For example, somebody is having the infection of the MERS coronavirus. You took a swab from his nostrils, from nasal passage, and you put it in the transport media. You send it to the laboratory. You add some antibiotics so that it cannot get the bacterial contamination. And in the laboratory, we use the tissue culture, laboratory animal or chick embryo, as I told you. Now, tissue culture. Tissue culture. You take the cells from the man or you take the cells from the animal. You put it in a glass tube, as I told you in the beginning, and cells are incubated and suspended with the tissue culture media. What is media? Media is enzymes, cofactors, glucose, hormones, and so on. And you can grow them cells in the laboratory. This is the tissue culture bottles. I told you in the beginning, right? It's the same. The bottle have containing the cells. And 3 types of tissue culture cells are there. How many? First is a primary culture. Is primary culture. It's taken from rhesus monkey kidney. Kidney cells from the monkey. What's the benefit of these cells? The characteristic is written in the red. You can use these cells only for 2 to 3 weeks. This is a kidney monkey cell. You add the tissue culture media. The cells are here. You can use it for 2. After this, these cells will be, or if you will not use them for the growth of the virus, automatically destroyed. Okay? So they have a limit. They have a limit. How many weeks? 2 to 3. Which type of virus can be grown? What? H0, HSV. Herpes simplex virus. And Warcilla zoster virus. Okay? This herpes simplex virus. So in the primary cell, this is one type. Okay? Second type, semi-continuous cells. You can take it from the embryonic tissue, from the human. How many times we can use this? 50 to 60 times. After that you can, if this is a stock solution of cells, you can take small amount, how many times? 50 times, but not more than that. The cell, it has been actually said before the 50 times, you should utilize themselves, otherwise they will have no use. And which virus can be grown? Yes. I will not ask, for example, a question like this way, tell me the semi-continuous culture, no. I will ask you, in your clinic, a patient comes and he is complaining of he is having a flu or something like this, which type of test you should recommend for the virus isolation? You have to write tissue culture. Tissue culture? Semi-continuous test. What's the characteristics of this test, of this tissue, semi-continuous? You have said that you have to write that it can be used up to 50 times. And what is the tissue culture? It's the living cell prepared in the laboratory. Fine? Very simple, and this is the example. No, one more. This is the another cell, continuous line. Continuous line. This is derived from the HeLa cells of cervical cancer. HeLa, she was a lady in England, and when she gave the birth, the 4th baby, it was a baby girl, and the doctor, her gynecologist, he collected her cells from the cervix that time without telling anybody, and he found the cells, they do not die at all. Those cells do not die. They were cancer cells. And the cells were named later on HeLa cells. If you search on the internet, just a few years back, the family claimed a huge amount from the government. Because why? Without informing them, the cells were used for the research. The lady died. She was having a cancer. Doctor was knowing that she will die. She is having a cancer. But without informing her family, he took the cells from her. Till now, up to this age, these cells are used for culturing of the virus, because primary culture cell, how many days? 2 to 3 weeks. These for her 50 times, but this cell, lifelong. As much as you want, you can use it. So that time the cells from her cervix, they were stored, and now they never die. Going replicate, you are adding this tissue culture media, these things, and the cells are growing. And they are used in the virology lab mostly. Now, khalas, this is finished. Okay? Similarly, you can use chick, aberrate, other, but the tissue culture is very important. Because tissue culture is specifically used for the growth of the virus. Primary culture, used from monkey kidney cell, 2 to 3 weeks. Then semi-continuous cells, they can be used for 50 times. They are taken from the human diploid cells. Continuous cells, these cells can be utilized for the whole life, because these cells are taken from the cancer patient, cancerous cells, okay? They never die. They grow. You put them in the media, they never stop dying. They are growing. Now, this is take the same. Now this cell from the tissue culture cell. Okay, this is a tissue culture cell. You infected this with virus. Infected with that virus. Infected with that. This is another test. And you put RBC. Human, either sheep RBC or whatever. If the cell is infected by the virus, the RBC, this is the RBC, the RBC cell, this is the virus, and the RBC gets attached here. Remember, it does not destroy. The virus is infected by the cell. The virus has infected the cell, or the cell is infected by the virus. You add the RBC, and the RBC gets attached to it. It is called heme adsorption. It's called as heme adsorption, not absorption. Adsorption. It just attached here on the side. Absorption means something go inside. Adsorption. Heme adsorption. Example is a herpes simplex virus. This is one more test we can done for a virus is present or not by the heme adsorption test. If the cell is not infected by the virus, the RBC will not attach. The RBC will not. Second is heme agglutination, and examples are given there. And heme agglutination inhibition. This is clear. Heme agglutination inhibition, and neutralization test. I will tell you in 3 minutes, but if you keep your brain active. The concept of the concept of heme agglutination and heme agglutination inhibition is based on RBC, is based on neutralization test, it is based on a cell, it is based on there is a difference, okay? A tissue cell. This is RBC. What is present on the surface of RBC? Quick. What is present on the surface of RBC? Various types of antigens, very good. Various types of. One thing is present on this RBC, I want to tell you, it is called as salic acid. Salic, S-A-L-A-I-C. The salic acid is present on the surface of RBC. Salic acid is present on? And this is the virus. This is that. On the surface of the virus, it is present on heme agglutinin protein. Heme agglutinin protein is present on the surface of? On the surface of RBC. What is present? Salic acid. If person is having the influenza infection or MERS infection, okay? What will happen when virus enter into the cell? It will attach to this RBC. This is RBC, and this is the virus. This is the virus. It gets attached. It gets attached to it, and this is called heme agglutination. This is called as on the surface of the virus there is. On the surface of RBC there is salic acid. On the surface of virus, heme agglutinin protein. Heme agglutinin protein has a strong binding for salic acid. It binds with it. It binds with it. So if virus is present like influenza virus, it immediately binds with the attack with the surface of RBC. This is called heme agglutination. This is the test tube. This is the test tube. And you add the virus. You add that virus. Which virus? Heme agglutinin virus. And you add the RBC. You add the RBC. And if whole glass look like red, from the top, if all looks like red, you see it look like all red, and then it is called heme agglutination. It is called as what is heme agglutination inhibition? Now, once somebody is having the infection of the influenza virus, the heme agglutination reaction will occur. Definitely, it will occur. After some time, what will happen? Our body will produce antibodies. When antibody is produced now, this antibody will take up this virus. The virus is taken by? Produced by us. And RBC is free. This is called heme agglutination inhibition. If the complete explanation I will give you in the second year, inshallah. But this time you have to just remember the concept. This is called heme agglutination inhibition. When we see in the glass tube this reaction, this is virus, this is now antibody, and this is RBC. But in this case, the RBC will settle down. RBC will? Why? Because antibody has taken up the virus, and the RBC is free. This is called heme agglutination inhibition. This is called heme agglutination. Why? Because both virus and RBC are attached. There is no antibody present. Finish? And now neutralization test. Neutralization test is the same, but here it is cell. It is cell. If virus has capability to bind the cell, if it damages the cell, it's called the neutralization effect. And if antibody is present, it will take up the virus and cell will be free. This is called a neutralization. In the neutralization test, you measure the antibodies. The purpose of neutralization test is to measure the antibodies. More number of antibodies, more number of viruses will be taken up, and cell will be not affected by the virus. So this is difference between heme agglutination inhibition, and neutralization test. In the heme agglutination test, RBC is the main thing. On the surface of RBC, there is presence of salic acid. Salic acid has a capability to bind with the heme agglutinin protein. Heme agglutinin protein is present on the surface of the virus. One example, influenza virus or Middle East Respiratory Syndrome coronavirus, that causes the MERS. They have a capability to bind. When RBC is taken up by, but not destroyed, not the lysis of RBC, it's taken, it binds with the RBC, and this is called as heme agglutination. And when antibody comes in between, it takes up the virus, and job of antibody to clear up antigens. When antigen is removed, the cell is free. This is called heme agglutination inhibition. And in the neutralization test, we do not use the RBC, we use a cell. And cell is, when cell attacks it, same inclusion body effect. But if there is presence of antibody, it will stop the virus to attack on the cell. This is called a neutralization. Basically, neutralization test famous we do for HIV. We do for HIV because it measures the quantity of the antibodies. Fine? You see, guys, this is the example. This is red. What does it mean? Heme agglutination. What does it mean? What is this? Very good. You understood. This was my point. This is overall reaction. But when the reaction is completed, this is virus and RBC, virus and RBC, virus. And now, what happened at this point? At this point, the virus is very little. Virus is, it does not cause heme agglutination. So this is the positive, this is the indicator, 64 titration result. Okay. And this, two things are in this point. At this point, virus has no effect. Virus has?
No effect.
So this means this person has lowest concentration of virus, lowest. But why virus did not affect? Antibody. Highest concentration of antibody. That I want to tell you. This is the purpose of this test, heme agglutination test. This gives you an idea at what concentration, lowest concentration, that virus has no effect at all at this point. And at what concentration it has a highest concentration of antibody. Here it is present of antibody but no effect. Antibody cannot control. But at this stage, antibody overpowers the virus, virus concentration decrease, antibody concentration increase. And usually in terms of serology, fourfold is considered as an effective. Try to read it. 1, 2, 3, 4. Fourfold increase, and it shows that. So when the antibody in our body it increases, like in the titration fourfold, it should increase, and then it can inhibit or eliminate the antigen. This is the chicken embryo. This is just for your information. And now serological diagnosis. Western neutralization test is clear. Western blot is heme agglutination inhibition. Now this I will tell you. What is ELISA? You might have a lab for this, right? Biochemistry. What is ELISA? What is ELISA? What is ELISA? What enzyme? Enzyme, E for enzyme, linked immune sorbent assay. Forget these two. This is enzyme. This is linked. It has been linked. It has been to immune. Immune yani antibody. Enzyme linked immune sorbent assay. Something is linked with the antibody, and this makes a test. It's called as ELISA. It's called as ELISA. So, what is the principle of ELISA? Either to detect antigen or antibody. To detect antigen or antibody. See how. What is the role of enzyme here? I will tell you in the one example. ELISA has 3 types: sandwich, indirect, competitive. Actually, it is direct, indirect, and sandwich. This is antigen, okay? This is antigen. Please, just I will take few minutes more. And you add the antibody. You add the here you add the antibody. Here you add another antibody. But this is enzyme linked. This is the antigen. You add that. This is called as a primary antibody. This is called as a primary antibody. And this primary antibody recognizes the antigen. Recognizes that. But reaction is not complete. Now it is important. You add enzyme linked antibody. You add another antibody. It's called a secondary antibody. This antibody will recognize this. This is the primary antibody. Let us see outside what happened in one antibody. And you add enzyme linked antibody. Enzyme linked antibody. This will link here. And this is your antigen. This is antigen taken up by the antibody. Now, when you add another antibody with enzyme linked, sorry, it attaches here. And you add substrate. What is the substrate that we use in the ELISA? Famous substrate that we use. You should know this. HORSE. HORSE. Horseradish peroxidase is a substrate that is used in the ELISA. That is used in the. When you add this substrate in the next step, this is enzyme liquid. And now when you add the substrate has a capability to bind with the enzyme. To bind with the, it will bind here. Enzyme and substrate will bind here. It will bind to the enzyme. And result will shown be in color. If it is colorless, and now when color is produced in the reaction, it is considered as positive. So in the ELISA, you have an antigen, you add the antibody primary, then you add the secondary antibody. Secondary antibody is with the enzyme, and then you add the substrate. The substrate will bind to this enzyme, and in the machine you see the change in color reading. Change in color. More the color means the more presence of antigens in the patient. If there is no color, nothing, this means this reaction has not taken place. The substrate did not bind to the enzyme, you do not find any result. Or this antibody has not, enzyme linked antibody has not bind with the primary antibody. This is called as indirect. This is called as, now remove this. Direct enzyme linked. Only one step. This is enzyme, and you add the substrate here and see the color reaction. This is called direct. This is called as direct. Now what is sandwich? You put the primary antibody, then you put the antigen, then the another antibody with the enzyme. This is sandwich. This is, see here. Clear?
Yeah.
This is the neutralization and heme agglutination. This is, I told you, heme agglutination is based on RBC. It's based on
Neutralized antibody.
this here. And this heme agglutination inhibition. And neutralization test here. No cytopathic effect means neutralization test, because no virus, so nothing here. If the virus has affected the cell, it is the CPE effect, and when antibody comes, it stops the growth of the virus, there is no cytopathic effect. This is called neutralization test. And this is called heme agglutination inhibition. This is called heme agglutination. Any questions here in this picture? You will not understand this. Because this is the Western blot. In the Western blot, you extract the DNA from the HIV patient. You have no DNA. You put it, DNA, on a paper, filter paper. And then, to that filter paper, you add the probes. You add short sequences of the DNA, not like PCR. those probes have a capability to find the DNA, either the DNA or the protein or the proteins of the DNA that codes for the protein of the HIV or that. Then you put a layer of papers on it and you keep it for incubation. Then after that you see the results, had probes binding it or not, and then you see observe results like this. So you just, and as such example information, this is called a western, actually two blot, northern blot, western blot and southern blot. Each is one for DNA, another for RNA, another for protein. But for you guys, I think this is just for the information that western blot is used to do the test to find the sequences. You see here, HIV protein is antigen separated by the electrophoresis and blotted on the nitrocellulose paper. Then you see the proteins of the suspected microorganism. That's it. Thank you so much. So now, maybe question will be based on picture based or an case scenario based. It's very simple. Fine. For example, I told you ABC Ahmed comes to your clinic with the MERS. You are suspecting he is having the MERS infection, yani coronavirus infection. Which test you will suggest, or what laboratory test can be used to confirm this disease, like influenza or tissue culture is very good. You can do a tissue culture
Or continuous.
Continuous.
or continuous, and apart from this, you can do what? Heme agglutination. Heme agglutination. You can do also the PCR, but there are a priority to do the tests. You cannot ask the patient go for the PCR because very expensive test. Heme agglutination, very simple test, 2 to 3 minutes. You need just blood sample, and what you need, RBCs, and you mix them and you see the result. For PCR, you have to wait 1 day, 2 days. Similarly, and for virus isolation, you need to send it to a tissue culture lab to grow culture, but you should at least know the tests. Fine? Thank you so much. Any questions? Your next class, all right? Yeah. At 9?